So hello, this is problem 110, balanced binary tree. So we are given a binary tree and we don't want to determine if it's height balanced. And we have the definition of height balanced. Height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differ by more than one. This is the definition of balanced binary tree, and we want to return either true or false. So if it's not height balanced, we return false. For example, let's take this example 1. 3, 9. For example, let's take this example. So for 3 here, 3, 9. Okay, there is no need to draw the example. 3, 9, 20, 15, 7. So if we look at every node, for example, let's take the node 20. So the left subtree and the right subtree do not differ by more than one. So it's balanced. Also the same thing for node 9, also for the node 3. Let's take now, for example, the example 2. This is node 2. So the right subtree has a length of 1, and the right subtree has a length of 1, while the left subtree has a length of 3. So in that case, our subtree is not our binary tree is not balanced. This is the problem. So I will try to solve this problem. So to check if it's height balanced or not, we need to check at its height. For example, let's take this example 1. For example, let's start by the root node, which is 3. We need to check the height of the left subtree and the height of the right subtree. And if the absolute difference between them is more than 1, in that case, our binary tree is not balanced. And how we'll try to calculate the right height of our subtree and the left height of our subtree. This could be done using recursion. So if our right height, for example, is empty, in that case the right height is equal to 0. Else the height is equal, we will increment it to 1 plus the maximum between the left height of the child and the right height of the child. For example, let's take this one. For example, we have, let's take this root 3. So what is the height of our tree? So we need to calculate the height of the left subtree, which is this one. The height of the left subtree is equal to 1. We will because this node 9 has no children. And the right subtree, how to calculate the length of it? We need to increment 1 plus we calculate the length of this subtree. Let's call our function, our recursive function, call it height. We need to add to 1 plus height of node point right, not dot right. And this one how it is calculated. So we need to calculate the height of the left subtree and the height of the right subtree. That's it. That's it. So, and we need at every node to check if the absolute difference between the height and the right subtree is more than 1. In that case, we our binary our binary trees will be not balanced in that case at each node. If it's not balanced in that case, so the big tree will be automatically not balanced. This is the overall idea. So we'll try to write it to understand it better. So we need to use a recursion function called height, which take node. So we need to calculate the height the height of our tree. We need to calculate the right height of the subtree and the left side and the left height of our subtree. So right height, let's call it height, is equal to height of node that right, and left height is equal to height of node dot left. So if the absolute difference between the left height and the right height is more than 1, in that case our subtree will be not balanced. Starting from the node, for example, let's call it n. So if absolute difference between left height minus right height is more than 1, in that case our subtree is not balanced, and else we will return 1 plus maximum between so let's take, for example, this example. Let's take our root is 2. So the height here is equal to 1 plus the maximum between the right height, this one, which is 1 in that case, and the left height, which is 2 in that case. So the height of this node 2 will be equal to 3. So return 1 plus maximum between left height and right height. So that's it. And we need to check if right height is equal to -1. Return -1, and to check also if left height equal to -1, return -1. And at the end we will check if we will execute our recursive function and pass it parameter our root. So So return height of root different than 1. So different to -1. So if it's if our recursive function has returned at -1, this means it's not balanced. And we have forgot the base case of our function. It's not node return 0. For example, this left sub3. So let's take the left subtree of this one and the right subtree of this one. Both of them are empty. So in that case, the length of it is 0. This is our base case. It's necessary. So that's it. This is our solution. This is actually we are performing here a DFS. So to calculate the height of this one, we need to calculate this one and to calculate this one, the height of the left, then the height of the right. Then based on that, we calculate the height of our root. So this is a DFS solution. I think, I'm not sure, it's called post order or pre-order. We calculate the left, then the right. Well, no, so it doesn't matter. So either we calculate the right children first or the left children. So it's a DFS with that's it. It's depth first search, and we're using recursion to do it. So that's it. The time complexity of our solution is linear. We are traversing all nodes, and the space complexity for this solution, since we are using recursion, so there will be like a stack in the memory, and the size of the stack could reach, for example, let's take this one, this example, for example, this one. At maximum, it could reach, for example, let's call it h. So time complexity of O of n and space complexity of O of h due to the recursion and the stack. This is our solution, and hope you liked. Bye-bye.
Me cuelgues a